Last Wednesday, we started with chapter 17, and then we learned that one main idea for us to use the t-test, or the main thing, is that when we are not given the population standard deviation, and then it means that we have to lean towards the t-test. Or if we are supposed to use the sample standard deviation, then we have to use the t-test and not the z. So we learned that last Wednesday. And then last Wednesday also, we learned how to compute the critical t value. And then I remember we did homework 3 and then 4. Well, in addition to you not having the population standard deviations, there is some assumptions and conditions that you also need to know to use the t-test. But the main thing that differentiates the z-test from the t-test is you need to ask yourself, is the population standard deviation given? If it's not, then you should be able to know that you are leaning towards the t-test. The other conditions include the independence assumptions, which means that the data value should be mutually independent. It is the same understanding as we did for the in chapter 16 for the population proportion. Also, randomization, which means that the data value should also be selected at random or simple random sampling. And then also, you should also know that the student T won't work for small samples that are badly skewed. So if the sample size is small and then it is heavily skewed, it means that the t-test won't work. And then there is another condition which is the nearly normal condition, which means that if the sample size is less than 20, then the data should follow the normal model pretty closely, which means that if the sample size is less than 20, we don't want it to be heavily skewed. We want it to be fairly symmetric. And then if it's between 20 and 30, the T would work as long as the data is unimodal and then symmetric. How do you determine that? You can determine that by making a histogram. And also when the sample size is larger than 30, the T method should, unless maybe the data is extremely skewed or like there are no outliers or stuff like that. So now we want to proceed to do some calculations. So let's try this example here. Now, when we look at this example, it says that a scientist, so I'm going to do it using two methods. One method would be to do it manually. The other method would be to use StatCrunch. Now, the question says that a scientist took a simple random sampling. So the SRS stands for simple random sampling of 150 salmon from a fish farm, from a farm. So it means that there is a farm, right? And then he did simple random sampling of what? 150 salmon. Is that okay? So from here, we can all agree that the sample size is 150. Correct? Okay. So we can see our N is 150. And found out the mean of the Myers concentration. So what is the mean? The mean is based on the samples that he took. Is that okay? Does that make sense? So the mean here is the sample mean. So we can see X bar is equal to 0.0913. and the standard deviation of, so the standard deviation is also based on the sample, because that is the sample he took and he got the mean and then the standard deviation. So the standard deviation here is the sample standard deviation. So we have S to be 0.0495. It is very important that you know, or you are able to distinguish what you were given. Is it the population standard deviation or is it a sample standard deviation? In this situation, you could clearly see that he took a sample of what? 150. And then the measurement he took is based on the sample. So those measurements are what? Sample based. Is that okay? So the mean is a sample. The standard deviation is also the sample. Is that okay? And then we are asked to find the 95% confidence interval for the mean merest concentration in the farm-raised salmon. So now we can see from here that the population standard deviation is unknown. We do not know. All that we know is the sample mean and the sample standard deviation. Based on this, it gives us an idea that we are going to use the T distribution. Is that clear? So based on the T distribution, let's go through our notes. How do we compute the confidence interval for the T distribution? This is the confidence interval for the T distribution. Is that okay? So let's write that. So I have X bar minus T star n minus 1 times S divided by root n, X bar minus T star n minus 1, here is plus, times S divided by root n. So what I want from you now, we have most of the parameters here now. What we do not have here is the critical value. So last time I taught you how to get a critical value. So I want you to go to your StatCrunch and now tell me what is the critical value. So tell me what T star, our n here is what? 150 minus 1. What is the critical value? So open your StatCrunch and tell me so we could be able to move fast. Mm-hmm. 1.9760. Did you all get that? Who got something different? Do you all agree this is the critical value you got? Okay. So if that is the case, it means that we can now solve the confidence interval by hand. So let's try to do that. So it means that this is going to be, what is our X bar? X bar is going to be, so even before we do that, why don't we try to get this thing here? Is that okay? Or you can still write it. So this is going to be what? What is our X bar? 0.0913 minus, we got 1 point, let me write it here. So the X bar is 0.0913 minus the critical value 1.9760 times the sample standard deviation 0.0495 divided by square root of n 150. and then same thing, 0.0913 plus 1.9760 times 0.0495 divided by square root of 150. So you see, this is how to be able to compute the confidence interval manually. And so now you can use your calculators. So now let's use our calculators to be able to get that. So why don't we multiply this first? Let's try to do that. So when I multiplied, I got 0.0913 minus the whole of this times 1.9760. I got 0.0798. Did you guys get that? Try to multiply, find this and multiply it by this. That is what I got. So, and then there's going to be 0.0913 plus 0.0798. So then the confidence interval is going to be 0.0833. And then I got 0.099. Did you all get that? So the rest is just computations. It's very important that you also use your calculators to see if you are getting the same thing. That way you learn how to do it properly. Okay. Now, if this is the confidence interval, we want to learn how to interpret it. So who would help us? What should be here? What should be in the first dash? What should be here? I am 95% because that is the what? The confidence level. Is that okay? Okay. That there, what should be here? What are we dealing with? We are dealing with what? Means. Is that okay? So that the what? Here is going to be what? The mean. Is that okay? We also dealing with the level of marks. I wrote that for you. So I am 95% confident that the mean level of myris concentration in the farm raised is between, then you write them. So you write the lower one first, 0.0833, 0.099. This is how to do it manually. Now, let's use StatCrunch to do it. So I'll start and then you also follow with your StatCrunch. So I will encourage you to open your StatCrunch. Do you all have your StatCrunch opened? It's very important you know how to use StatCrunch to do this. So we go to stats and then T stats, one sample, and then we go with summary. starts, T starts, one sample with summary. Okay? So I will proceed. Now let's input. What is our sample mean? Our sample mean is what? 0.0913. Or you could also open the slide. You could divide your StatCrunch into two and then open the slides and also double check. So let's input our sample mean. Our sample mean is what? 0.0913. Is that okay? Then we proceed to input our sample standard deviation, which was what? 0.0495. Is that okay? What is the sample size? 150. And then we click here. We are interested in the confidence interval. And then the confidence level is what? 95. So we leave it as 95. Is that okay? And then we could show the critical value. And then we hit compute. So you can see the degree of freedom is what? N minus 1, which is 149. And so you can see that is the lower limit, which is correct. And then the upper limit, which is also the same as what we got. Is that okay? So this is how to use StatCrunch to solve this kind of problems. Is that okay? Okay. Now let's proceed to the next one. So for the next one, we have this. If you want to do this manually, it means that you have to compute the sample mean and then the sample standard deviation, which is going to take quite some time. So we are going to use StatCrunch to be able to do this straight up. So to be able to do that, let's open our StatCrunch and then let's input these. So we are told that a company has a set goal of developing a battery that lasts over 5 hours, which is what? 300 minutes of continuous use. So the first 12 batteries, so these are what? The number of minutes they computed for the first 12 batteries. And then the question is that, is there evidence that the company has met its goal using a what? 99% confidence level? So to be able to answer problems like this, we need to open StatCrunch and then we can. So here you can see that we have to compute the sample mean and then the sample standard deviation by ourselves. Is that okay? So that also gives you the idea that we are going to do T. So let's open StatCrunch and then input the numbers there. So let's input the numbers. I have, so input yours. So I have inputted mine. Is that okay? Good. So let me change this var1 here to minutes. So once you have that done, now we go to, because we are interested in computing the confidence interval. Now we go to stats, T stats, and then one sample. But this time around, we are not going to do with summary. We are going to do with data. So one summary with data. Is that okay? So to compute the confidence interval for this, we go to stats, T stats, one sample with data. Is that okay? Good. And so there we go. And then we select the column where we inputted our data. For me, I changed the name to be minutes. If it didn't change yours, it's going to be like var1. So you select that. So you select that column and then you come down. We want the confidence interval. Is that okay? And so you have to change the confidence level. In this example, the confidence level is what? 99. So you change yours to be what? 0.99. Is that okay? Then we want to show the critical value. And then I hit compute. So you can see when you do that, it gives you the lower limit and then the upper limit. Is that okay? Good. So I want to ask you, has the company achieved its goal? If yes, why? If no, why? What do you think? Why? Okay. Anybody else? Adlen, what do you think? Abby, what do you think? Okay. Anybody else? How many of you think no? Raise your hands. How many of you think yes? Raise your hands. Okay. So the company's goal is what? 300 minutes, isn't it? So to be able to answer that, you have to focus on the interval. Is a 300 between the interval? We're looking at this interval. Yes. So not only the lower limit. So it's like a range. If it's between the range, then yes. Does that make sense? So you can see from here, the lower limit is 279, but the upper limit is 332. 300 is between these limits. Is that okay? So then yes. Is that clear? So not only the lower limit, but you focus on both the lower limit and the upper limit. And you ask yourself, is what you are looking for within that interval? Is that okay? If it's within that interval, then yes. Okay? Good. So I'm going to write the lower limit here. So we have 279.97 and then 332.52. Who is going to help us with the interpretation? So how do we interpret this? So the first thing is what? 99%, isn't it? So 99% confident that the what? What should be in the next dash? You are 99% that the. So here we are looking at what? The mean lifetime. Okay. So that the what? The mean lifetime is between, then you write a lower limit and then the upper limit. Okay. That is how to interpret the confidence interval. Okay. Let's try a homework problem. I want you to open to your homework, chapter 17 homework. Let's do question 19. Do you all have question 19 opened? Okay, waiting. Do you all have question 19 opened? Okay, so let's try to do question 19. So we are told that psychology experiments sometimes involve testing the daily ability of rats to navigate mazes. So when you read, we are told that as measured by the length of time it takes for us to find the food at the end. So the researcher needs a maze that will take an average of about 1 minute to solve. Now, he tests one maze on several rats. Collecting the accompanying data, you should also assume the data arose from a properly randomized experiment. You've been told that. And then we are asked to complete parts A through D. So we are asked to find the 99% confidence interval for the mean time to find food. So this is that when you click on this, you see a data here. Is that okay? And then when you click here, you can click on open and start crunch. Okay. So when you click on open and start crunch, so you can see from here, you are going to use T. Is that okay? Does that make sense? This is very clear because you don't have the population standard deviation. All you have is the what? The sample data. Is that okay? So we click on open and start crunch. And then there we go. We are interested in the what? 95% confidence interval. So we have this. We go to stats. T stats, one sample with data. Is that okay? Stats, T stats, one sample with data. Okay. And then there you go. We click on the column name, which is the time second. And then we click on confidence interval. The confidence interval is what? 95%. So we have this 95%. And then we click on show critical value. And then from there, we can click on compute. So you can see from here, this is the lower limit, and then this is the upper limit, isn't it? So from here, you can be able to what? Answer that problem, which is the lower limit is 46.856, So you're asked to round to 2 decimal places. So 46.86. And then 59.30. So there we go. The next one is to what? We are asked to plot the data. And so when you look at this, we have to what? Construct the what? The histogram. Is that okay? So I come here, I close this, and then I go to graph histogram. I click on that. I do this one here. And then let me change the width here. Let me use 5 to see. And then when I hit compute, there's a histogram I got. Okay. So you just have to look at which of them matches this histogram. Let me look at my histogram again. I think it's C. Let me see. Yeah. So what stood out is that there is one thing here, and then you have this one here. And then you can check your answer. And then the next one, they want you to choose the normal probability plot. So we just want to do the QQ plot. So we come here. We still go to graph, and then we see QQ plot. Is that okay? Choose this one. And then we hit compute. So when you look at the QQ plot, you can see it's fairly straight line, except I can see one outlier here. Based on my data, I could see there is one outlier here. Okay? So you just need to choose that. So in my case, I think the right answer should be C. And then they're asking you, are the conditions met? So you have to, so like we've been told, that is randomized. So we can see that the randomization condition is met. And then there's the QQ plot. It's not roughly straight. This is roughly straight. So, um, so what do you think the right answer should be? So I'm thinking it's D because the randomization condition is met. The probability plot is relatively straight with one outlier. Without the outlier, the condition to met. The histograms is roughly unimodal and then symmetric. So I think should be this one. Yeah. And the next one is saying that you should eliminate the outlier and find a confidence interval again. How do you do that? So you come here. How do you eliminate the outlier? Just click on the outlier here. Okay, this is the outlier. Is that okay? When you click on this, it shows you where it is. And then go on that and then delete that. Delete that row. So you can see I delete the row. Okay. And then now when you delete that row, you can now compute the 95% confidence interval again. So you repeat the same process and then you're going to get that done. Any questions on that? So I'm not going to do the confidence interval again because I think you should be able to know how to do that now. So let's proceed then. So this is the interpretation I wrote for the first one that we did. Now we are going to talk about bootstrapping. So the idea behind bootstrapping is that sometimes the population is not there. Is that okay? So sometimes all we have is the sample. Is that okay? When we don't have the population and we have the sample, say for example, there's a sample of say, let's say n is 10. So what bootstrapping does is that it's going to resample from the sample many times. Is that okay? So that is the idea behind bootstrapping. So it's going to select sample from the sample with replacement many times. Is that okay? And then we're going to compute the confidence interval on them. So when you look at this one, if n is 10 here, and let's say that, so it's going to select samples from here, sample from here, sample from here, so many times. So for example, if let's say that here is a 2, 4, 6, 8, 10, 12, 14, 16. And it's supposed to select maybe 3, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You want to select 10. So it can take 2, 2, 2, 4, 4, 4, 3, 1, 3, 3, 5, 6. Is that okay? So when it selects, it could put back. So it's going to do that many times, compute the mean here many times, many times. You're going to do that several times. Is that okay? So it's going to select many samples from the sample. So that is like what? Resampling. That is the idea behind bootstrapping. So now we are going to learn how to use bootstrapping to get the confidence interval. So I want you to open StatCrunch and input this data. We are going to use StatCrunch to be able to compute this confidence interval. We are going to do that using bootstrapping. So the first one, you already know how to do that already. So you can do that. And then let's assume that the conditions for T is not met. So let's find the 95% bootstrap confidence interval. So we are going to do 2. For A, the first one, that is what we've done already. You've done an example in your homework. So let's ignore this one. And then let's do 2. Let's try to find the bootstrap confidence, 95% confidence interval for that. So all you have to do is to input the data in StatCrunch. So let's input the data. So I have been able to input the data, and then the data is what? It's about coffee. So I'll name this one coffee. So when also look at the last slide, I have shown you how to, when look at your slide, I've shown you how to use StatCrunch to compute the confidence interval for Bootstrap. So we are going to use bootstrapping. So to be able to do that, first step is to be able to what? Input the data, which we have done. Second step, we go to stats. Then we go to resample. Okay? Stats, resample, and then statistics. Stats, resample, and then we go to statistics. I will encourage you to follow. I click on that. Is that okay? Now, I choose coffee. Okay, the column that we are interested in, which is what? Coffee. The next thing you want to choose is to choose build. Click on the build. Have you all done that? Now scroll here and find the mean. Let's scroll. So if I have the mean here. Is that okay? So you see, you scroll through the functions and then find the mean. Is that okay? So when you find the mean, when you click on that, it's going to appear here. I double click on it. When you double click on it, it's going to appear here. Is that okay? How did I get here? When you get here, we go to build. Now scroll through this and look for the mean. Is that okay? This is the mean. Double click on it. I have it here. Is that okay? Mean of what? Mean of coffee. Double click on the coffee too. Is that okay? Can you all see that? Okay. And then now we click on OK. So you can see it comes here, mean coffee. Can we all see that? Okay. Now we have to make sure we click on the bootstrap with replacement. Okay. The computer is going to do it for you, so you don't have to worry. So bootstrap with replacement. And then the number of resamples, we set it to 1,000. We want many samples as much as possible. So it's going to do that several times for what? 1,000 times. Is that okay? Good. And then we want to also click on the store resampled statistics in the data table. You would want to click on the store resample statistics in the data table. Okay, good. Then we keep scrolling. And then let's maintain the percentiles. Let's not change the percentiles. Now I'm now going to show you how to get the 95% confidence interval. So maintain this. Is that okay? Are we all okay? Good. Now you just have to hit compute. So when you hit compute, you can look at this. You see it will sample this, find the mean. So it has done that several times for 1,000 times. So when you scroll, you are going to get 1,000 times of that. Is that okay? Now, when we have this here, let's focus on the table here. This is the 25th percentile, okay? 5th percentile, 50th percentile. I want you to write this 25th percentile, 50th percentile, 97th percentile down, because I cannot see this, so I'm going to my iPad. So when I request for a value, you just mention them. Is that okay? So you have this stored. Is that okay? Everybody's own could be different. Is that okay? So we have this one here. Now, how do we find a 95% confidence interval? So that is what I am coming to do. Yes. So to find a 95% confidence interval, now let's look at this one here. Okay? Is that okay? So if we have this one here, what are we interested in? We learned in previous chapters that the whole area here is what? 1. Correct. So if the whole area here is 1, we are looking for the 95th percent confidence interval. So here is 0.95. Okay? What do you think here would be? What do you think here would be? So we are left with 5%. Is that okay? So if you are left with 5%, divide 5% by 2. What do you get? 2.5. Is that okay? So the left side will be what? 2.5 or 0.025, right? Let me do that instead. So here would be 0.025. What do you think here would be? 0.975. Is that okay? 0.25, 0.9. So here is going to be what? So you are going to get a 95% confidence interval, we are going to look at the what? The 25th percentile and then the 97.5 percentile. Is that okay? That is going to give us the what? That is going to give us the 95th percentile. So when you look at our StatCrunch here, the 25th percentile is what? 9.76. What is a 97.5 percentile? 9.93. Is that okay? If you want the 90th percentile, we are going to look at the what? The 5 percentile and the 95th percentile. Is that okay? Does that make sense? If you want the 90th percentile, we are just going to pick because 90th percentile, we are left with what? 10%. 5% here, 5% there. Is that okay? So we are now going to look at the what? The 5th percentile and the 95th percentile. This doesn't give you the confidence interval straight away like we did for the T. Is that okay? So you have to be able to what? Do this. So I'll see you on Monday. Yep.